Hey everybody, this is Dustin Matthew over at Geek Boy Repairs, and today we're going to go over a few MacBooks. I had a client who his team is struggling a little bit with diagnosing MacBooks, so he asked me to make a video from start to finish. So he sent me a few MacBooks. I haven't even looked at them yet or even opened the box. Now I do know one of them was a MacBook Air with high fan spin. It was a 2019 MacBook Air, I believe it was. That's likely going to be the battery. I told him already to try that, and he said he did, but not that I don't believe him. It's just I've had multiple with bad batteries after the client said they had already tried the battery, and that's just because get bad batteries quite often. So, all right. So it looks like there's quite a few devices in here, an iPhone. Alright, that was super annoying. So essentially, I got the board out and already started diagnosing it, and then I realized it wasn't recording. OBS randomly stopped recording, so I'm not sure what that was about. But so now I get to start over again. A little bit more frustrated this time. Okay, so essentially I wanted to start by going over my setup. Okay, so, or I guess even this was missed. We're gonna start with the M1 no power. Okay, but I also wanted to mention my the way I have my charging setup, because this is very important on how you're diagnosing MacBooks. Okay, so let's go ahead and get started on that. The first thing that I want to bring to your attention is the charger that I'm using. This is an OEM. I buy it right from Apple, so I know I'm getting an OEM. It's the 140 watt, which is the biggest the biggest charger that those guys sell. Okay, this is made for like the newest 16-inch MacBook Pro. That way it can power it on, charge it efficiently. I use this because it will turn on every MacBook prior with no battery connected, and it has enough juice to do that. And so I can always rule out the battery by simply disconnecting the battery and plugging this in and seeing if it charges the battery or if it turns on whatever you're trying to diagnose. The next piece that I have on here is called the Power Z amp meter. Okay, this tells me that the rate of power that the computer is pulling with and without the battery connected. So this is a very useful tool. Mobile Centrics has it. It's like $100. You can use it on iPads, etc. And I also use this charger, the same exact setup, on iPads or USB-C based iPads. The next piece that I have here is the OEM USB-C to USB-C MacBook charger. Again, all of this was bought through Apple, except of course the Power Z. That way I know I'm getting the original and the right thing, and I do that because if it's not the original, then it might not power up the MacBook without a battery, and we need to know if the MacBook will power without a battery. Okay, so the first step that I always do, right, is I always plug in the charger to the MacBook. The first, see if I get any signs of life out of it with no power connector, and I do not, so I'm going to go ahead and connect the power cable. I'm going to look to see at my power draw, and if you can see that, I'm getting a steady 5 volts with 60 milliamps. And I'm not sure what the hell that balloon was going over the screen, but whatever, OBS. I'm getting 5 volts and 60 milliamps, and that's constant. That makes me think the unit has a PP bus G3 hot short, and since this is a M1 unit, it's actually called PP bus A-on. And the first thing that I actually notice is that the board has been worked on before. You can see flux all right here, and this coil has a little bit of burn on it, showing that it's had some heat there from somebody's heat gun. All right, so that's not good, right? We always want to see MacBooks that haven't been touched before. My first step is I'm going to put my multimeter into diode mode, and this right here is diode mode, okay? And I'm going to check and see if PP bus A-on is short. So let's see, that's this guy right here, and it is not short. That's not what I was expecting. I was expecting it to be short. So my next step is to simply plug in the MacBook, because the reason I'm thinking PP bus should be short, just to kind of elaborate. I went over this before when it stopped recording, but 5 volt 60 milliamp is notorious with T2 and M1 units when they have a PP bus shorts. All right, so that's like one of the first rails that got to power on. So when it's that low of a current draw, you think PP bus. Now it's not short here, so the next step is to simply turn my multimeter into voltage mode to tell me, to measure voltage. Okay. And then measure that line and see if PP bus is even being generated. Okay, so we're going to go ahead and do that. We'll switch you back over to the overview camera. And I'm not using my scope or anything for any of this, just because I know where this component is that I'm testing. I don't need my scope. And it's not being generated. It is sitting at 0.182 volts, which is nothing. So we found our issue. We know our issue is that PP bus isn't being generated. The question is why? So we're gonna go ahead and discover that. We're gonna try to figure that out. So we'll take this board out of the housing, and normally what I would do is, once again, I would test and see if I have PP bus generated even outside the housing. But I'm not even gonna do that, because I can tell you that it's not gonna be there because they've already messed with this board. So now we're gonna go to our scope. We're gonna do a visual inspection, a little bit more visual than we did before. So you can see here, this is what we spotted before, and there is just, yeah, there's a lot of leftover flux on the board. Not exactly sure what components they were changing. Actually, it looks like they have changed this here, and that's not on centered, so we'll have to address that. They burnt up the battery connector a little bit. Not that big of a deal. It happens when you're working with right next to it, but it looks like this one may have been replaced, but they did a good job on that one. This one looks very sloppy, so we're gonna go ahead and address that first, because that is part, if I'm not mistaken, let's go ahead and pull it up. I believe that's part of the circuit to generate PP bus. So let's go ahead and go to board view. I believe this is a 2016 board. Yes, it is. All right, good. That makes it easier. So it's this component here. So we're going to search that on the schematic, and let's see what it is. Yes, PP bus supply. So this is definitely something for PP bus. I didn't mean to open that. This is something for PP bus. So again, that's going to be needed. So we're going to address that really quick. And this looks like maybe we could just reflow it. We're going to find out here. And I'm not even going to try to clean up their flux. What I'm going to do after I'm done is put this board through the ultrasonic cleaner. And then that will clean up everything real nice. If I have enough damn EC cleaner, because I ordered some last month when I was running low, and they just shipped it last week, so I'm not sure what was up with that. We're just waiting for this to solidify so we can kind of get this into a better position than it is right now. Kind of expecting surface tension to kick in. Don't really need any flux, there's plenty there on the board. Oh. Alright, now I'm just going to remove it, because essentially there's not enough solder down there for the surface tension to kick in like I like. So what I'm going to do is I'm just going to address this as if I'm installing it myself. Add a little flux now that we're forced to. Grab our iron. Come on, heat up. I'm waiting for that to beep. There we go. Alright. Add some solder. Just like that. We're going to hit all of those. Make sure those all look like fluffy pillows. All these look like fluffy pillows. Now we're going to go ahead and take that chip that we set over here. We're going to do the same. Now we're just going to go ahead and lay this here. I'm going to wait until that solder melts a little bit, and I'm just going to pop the chip on top of it, and then it's not going to fly away. So bam, just like that. And I'm knocking it around. I'm waiting for it to go in place, right? So I know it's in the right position. Come on. There we go. That's what I'm looking for. Now I'm going to let it cool for a second, let that solder harden, and I'm going to press down with my tweezers, right? And then I'm going to heat it up again. I'm not pressing down too hard, just enough. And I'm waiting for all that solder to push out of there, all that extra solder. None of that's needed. And I'm just kind of waiting until that chip looks like it's sitting completely flat. Like, kind of like that. And then waiting for it to harden again. Perfect. Now we're going to take our iron. And we're going to clean up all that extra solder. So, oop, in here. Gone, gone, gone. Now, if we were being real picky, we'd go in and grab that solder ball in the middle. But I'm not being real picky right now. So, actually, yes I am. And that's going to bother me if I don't do that. So what we're going to do is real easy, because you can't fit your iron in there, right? Like that's not going to fit right. It's going to make more of a mess if you even try to put your iron in there, or even if you got a micro pencil, which I do, it will still, you're not going to fit that in there. Oh no, my wick is running away. Alright, so what we're going to do, we're going to get a small piece of wick. Alright, we don't need that big piece. We're going to stick it in there, and then we're going to apply hot air, and bam, it sucks it up just like that. Alright, so now we don't have to worry about that excess solder ball, even though it wasn't going to hurt anything anyway. Now, we are going to use the ultrasonic on this later, but just for my sanity at this point, Jesus, clean up some of this solder. No disrespect to the guy that sent this in there, no disrespect to your tech, but less flux is always good, man. You don't want to, you know, bury it in flux. And if you do have to, sometimes you have to. Sometimes you're just aggravated and you don't want to clean up your flux every step of the way because you're changing parts left and right. But yeah, try to clean your flux every step of the way. That way it doesn't look like this kind of a big gumped up mess right here that we got. Alright, so we're going to continue our visual inspection. We're going to wait for that to cool. And we're going to, normally we would test right away, but the board's still hot. So we're just going to continue our visual inspection. And when the board cools, then we'll go ahead and retest. I doubt that's going to be my only issue, but we'll see. So let's switch back over to the scope, make sure I'm still recording, because OBS screwed me last time. Alright, so really everything else on the top side of the board looks untouched. We do have PMICs and stuff like that underneath this heat shield, but we're going to hope that they didn't mess with any of that. Just to clear my sand and get this cleaned up. Beautiful, that's better than it was. Alright, so, oh man, we got more flux. This is the ISL, right? This is responsible, this is the chip responsible for creating PP bus, and you can already see there's a huge fucking chip in it. There's a huge effing chip in it. That's definitely going to be our problem, or more than likely for PP bus not being generated. It looks like they may have replaced it or refloated. They likely replaced it, but while replacing it, they damaged the new one. I'm not exactly sure. We're going to have to take this off. And this is the thing that I don't like about working after other board level techs. And no disrespect to anybody out there, but it's just, like, I don't know if this computer came in with PP bus not being generated, or PP bus being a problem, but likely not. And likely what's going to happen is after I repair this PP bus issue, then I'm going to be in a position where I got to figure out what issue the MacBook actually came in for. Right, like what was the initial problem with the MacBook? And so it's double the work, and people, you know, they want to try board level and they want to get into it, and I can completely respect that. I'm in the same spot. Before I was in it, I always wanted to learn, but I mean, it's just these are customer devices, and it's just, oh man, it stinks to see them destroyed like this. All right, so we're gonna go ahead and we just removed the ISL. We went ahead and wicked underneath it. Okay, what I'm looking for is any kind of damaged pads or anything that might be cause for an alarm. I don't see anything that stands off right off the top of my head. Everything looks pretty good except for the excess flux here, which I'm just trying to get rid of. Alright. Yeah, it's not going to be perfect until after I take it out of the ultrasonic. But we can at least make it look as good as possible. Okay. Alright, so that's good enough for right now. So we need to go ahead and lift one off our donor. Let me pull out one of these MacBook Air donors. Which one still has the ISL? They should almost all have the ISL, because I don't think I've ever seen an ISL on an M1 fail. Well, maybe one time actually. I'm lying to you. I think I have seen it before, but it's very rare. Like, I work on these things all the time. I don't see them fail often. So we want to carefully lift this chip. That way we don't gouge it out like the other technician did. So we're just going to be very careful. We're going to wait for the chip to be ready to remove right before we start like yanking on it. We're not going to yank on it at all. We're just going to gently touch it until it's loose, right? And it should be loose pretty soon, hopefully. It's not coming off. My mat was lifting, was bubbling as I was lifting the chip, making it so I couldn't remove the chip. Like the chip was lifting with my tweezers. Alright, anyway. I'm going to put that donor off to the side. We're going to move this chip somewhere else that's not on my mat. That way it's not bubbled up like it was a second ago. flux. And we're gonna get rid of all those balls. Try to make it look as even as possible, just like that. One more cleaning. One more. Come on. Perfect. That's good enough. Alright. Now we'll get our stencil. Gotta find the stencil that actually has the ISO. Nope. That's not ISO, is it? Yes, it is. Beautiful. Beautiful. Alright. Now we're gonna get some of our soda paste. Just a tad of it. Put that on there. I should be using gloves, but it's Sunday. It's Sunday. We don't care about our health on Sundays. No, I'm just kidding. I forgot to put them on before I started this repair. Alright, we'll be alright though. Alright, now we're going to reball this sucker. Alright, beautiful. Down. That's good enough. We're going to actually go ahead and give this one last reflow just to make all those balls look perfect, just like that. Now that chip's ready to go on the board, so we're going to let those balls cool. It looks like they just did. You don't want to move it around. Alright, so now what we're going to do is we're going to put that chip off to the side for a second. We're going to go back to our ISL area. And the first thing we're going to do is apply heat. Why are we applying heat right now? We are applying heat because I want to use as little flux as possible. So what we're going to do is heat up the board so the flux melts as soon as it hits the board, just like this. Boom. That way. You're barely using any flux. Oops, sorry for the fogginess or the out of focusness. Bam, so you use that little bit of amount of flux. The board's not going to look like it was hit with a flux disaster. Alright, so it needs to sit like that. Bam, just put that up in there. Grab another pair of tweezers. Another pair of tweezers, and we're going to go position it a little bit how we want it. Like that. We're going to come in with our hot air. And we're going to let surface tension go into place here. And there's surface tension working. It jumped into place as you just saw. And it's good to go. Now I have a sneaking suspicion that we'll now have PP bus generated at least, but we will not have a working computer yet. And that is why I charge a bench fee for if they've been worked on before, on the board anyway. Because essentially I could have fixed your mistake, but still not being able to figure out the actual mistake. It's not common. A lot of people don't know that I charge bench fees for no fixes, or because they're normally fixed, but you know it sucks for when they've been worked on before. Alright, so we're going to go ahead. The board's still a little warm. I'm going to clean my mat real quick. That way I can keep working on a clean surface. Should be cool enough to test with at least. Alright, so we'll switch you over to overview so we can see what we get now on the amp meter. Okay, I'm still getting, it's a little lower now, 5 volt, 45 milliamp. Let's see what we got on PP bus. Let's see what's on the PP bus. 12.31. So now we have PP bus generated, okay, but we're still not pulling nothing. Still not pulling nothing. Let's see if both ports are the same. They are. 5 volt, 40 milliamp, and PP bus is being generated. Let's see. I'm going to check around this Aeon circuit over here and see if I see any shorts. see if anything stands out to me. Check over here. No, not shorts. Not shorts. Check out over here. Make sure there's nothing there. And then I'm going to check the 3v3 circuits. So over here, the CD circuit, it looks untouched. So I'm going to just check and see if there's any shorts over here. I doubt there will be, but it's never bad to check. Alright, so we're going to go ahead and remove, sorry for the noises, the ultrasonic cleaner had to change out the water because I'm going to need to ultrasonic this board later. So I just realized that I didn't have anything in there, so or any water in there yet. Alright, so we're going to remove the heat shield here. Oh, god dang it, you're on the... We're going to remove the heat shield here, just so I can look at these PMICs to see if there's anything weird about them. I don't expect them to be, but I don't want to be like, if they had a hole in one, then it'd be so obvious, you know. But there's not, so we're going to go ahead and move right along. We're going to check a couple of basic voltages here. To start with, we're going to check with our Aeon circuits. Okay, so that's the circuit I was looking for, the 3V8 Aeon. That's like another main power rail that you see fail all the time, so we're just going to make sure that that one's present. So I already checked earlier to see if it was short, and it wasn't. So we can go right here and we're just going to check that, and that is also not present. Okay, so this is likely what the original issue was, and I say that because if we look on our scope, and of course my scope is frozen. Jesus. Alright, 1 second. Alright, sorry about that. The scope cam stopped working and I had to give my left arm to get it fixed. So it's fixed now, it's working hopefully for the rest of the video. Okay, so where we left off was that PP3V3 Aeon was not turning on, so we're in that same spot. So let's go ahead and go to Flexboard view. Sorry, starting kind of all over here because I had to restart my computer. Okay, so that was this line over here. 3V8 Aeon is not working. Okay, so we're going to go ahead and use a little bit of our experience and say, hey, that line is generated with this chip here. Okay, and that's just from experience, guys. You'll get there, and you can even see, it says right at the beginning of that top chip, 3V8 Aeon controller. How you could have found that if you didn't know where this chip was generated, you could have right-clicked, searched for that line, and then kept hitting next on the schematics until you got here. And eventually you would have gotten here. We're skipping ahead though because we have 3 MacBooks to work on and an iPhone. I doubt we'll get to that iPhone in this video though. Alright, so this is where that line is being generated at. So normally what we need for a line to be, for this to turn on and produce a 3V8 voltage is the voltage line coming in, which is PP bus Aeon. We have already fixed that, so we know that is working. Okay, and then it looks like we have an 5V S2 line. Again, experience will tell us that S2 lines are not that important until later. That's going in. This line is going out. We can see this little from the arrow. And this line is also going out. And then we need an enable, which right here, look at this, enable. It says it for us. Is the chip being told to turn on? So let's check. We can check here at this resistor and see R5710 and see if it's being told to turn on. So we're going to check for voltage there on this side, right? Okay, so we'll go ahead and do that now. We'll plug in the board to the power, and we will pray that our microscope is working. It is perfect. And there we go. Now we're in voltage mode. Let's see what the voltage is. Drum roll, please. It is 0.33. So it's not, this chip is not being told to turn on. So this guy's probably not bad, even though he does fail all the time. He's probably not bad here. He's just not being told to turn on. So what's the next step? What do we do here? We go back to this schematic and we follow this line and say, hey, where are you being told to turn on? So it looks like this is the delay for 3.8 VR enable. So this is what we need. Oh, look at this. It comes from charger in MVR. What does that come from? That comes from ISL, the ISL chip that we just replaced. We know it to, so we know the ISL is good. So it could be that this line is low, and we can go ahead and check that. Let's check that over here. There's a test point. That test point is down here. Oh, switch you guys over to the scope again. The scope, and that test point is somewhere right here, right? Yeah, that voltage is present, but look, as we're testing, we notice probably what our issue is. Look at that. There's a hole in this chip, and if I had to bet, that chip is this piece right here, U5340, and it is U5340. So, what is our issue? Let's recap here. Our issue is that the 3V8's Aon line is not turned on, right? It's off. It's at like 0.1 volts or something like that. So what did we do? We went to the chip that is responsible for generating that line. Okay, that was the Renaissance chip that you saw on the board. Okay, we said, hey, you have voltage coming in. We know you have voltage coming into that chip, but are you being told to turn on? And it's not being told to turn on. So we went even further back and said, hey, what tells that chip to turn on? Okay, and we found a little smaller chip that is responsible for telling that 3V8 on chip to turn on, and it has a huge hole in it. So likely that's our issue. So these guys, no disrespect to them, but they're over here changing the ISL, damaging the ISL, damaging one of the MOSFETs, and then it seems like they're just changing parts randomly to try to get to the issue. But you have to do it the way I just did, with following voltages, checking for shorts to see. It will save you a lot of time. Yes, it may take longer to learn how to do this stuff, but I can guarantee you're going to save yourself a lot of time in the long run by not swapping random chips and actually know what you're doing. Okay, so we're going to go ahead and change that chip out real quick, and hopefully this MacBook will turn on, and then we can throw it in the ultrasonic cleaner, which is should be ready in the next 10 or 15 minutes to accept the board in there. So let's go ahead and do that. First, we're going to just take the chip off here. Is my scope broken again? No. Okay. I don't know how I missed that chip having a hole in it right next to the ISL. I guess I was so infatuated with the way the ISL looked that I wasn't really looking around at anything else. But yeah, that chip having a hole right there, that's no good. That's actually bad. And I don't think the technicians did that when they were replacing stuff. So I think that's probably why the actual MacBook came in. So, and see, if this MacBook came in just with this hole to me or to somebody with a bit more experience, we wouldn't have to put this board in the ultrasonic. We wouldn't have to really, this probably would have been a 5-minute job to see, oh, you know, that line's not being told to turn on. Why is it not being told to turn on? Oh, bam, look, there's a hole in this chip. Or a good visual inspection would have also done the job. If I would have really looked at this board close enough, I probably would have been able to find that without even using the schematic or board view. Come on, iron, get hot. Get hot, iron. We're all waiting on you. There we go. Ooh. I'm just touching these with, you know, some solder, some fresh solder. We're going to put the client's board to the side. We're going to pull out that donor that we had earlier that we took the ISL off of. And look, this chip doesn't have a hole in it. That's good. We might be able to use that. Now, the question is, how did that chip get a hole in it, though? That's curious. I'm trying to think, there's only a 5-volt line powering it. I don't know. I didn't see any liquid on the board, so. Alright. Perfect, that jumped in place. Now we're going to let the solder harden just like on that MOSFET we did before. Press down on it a little bit. Hopefully this goes quickly. It's starting to burn my fingers. Not in a good position. Whew. That was toasty. That was toasty. kind of clean up some of our flux there. Bada bing. Alright, and again, we're not being perfect just because this board is going to go into the ultrasonic here shortly, and all this will look like it's never been touched. Alright, so we're going to wait for that board to cool before we test again, and we'll have our fingers crossed that we actually fix this board and that the other ones don't look like this. So we'll just wait here for the, hopefully that ultrasonic will be done shortly, so I don't have to put this aside and then come back to it. I like to just put them all back together once they're done instead of having to wait for them to be clean. Alright, so the board's cool enough now, hopefully. Let's see what we get. Alright, we're already getting better. We got 5 volts, 20 volts now. Yeah, we got a booting MacBook. Okay. So what we're going to do is we're going to put this back in the housing real quick. I'm not going to put the heat shield or anything like that back on because, like I've mentioned, I think 5 times now, I am going to ultrasonic this board, and I just want to make sure it turns on. Go ahead and plug everything in. Alright, those don't need to be plugged in. So I'm just looking, well, I might as well plug in the battery. So I'm looking for Apple logo and it that boots to the lock screen. And if it does that, I will be satisfied enough to put it in the ultrasonic cleaner and then finish diagnostics. Like doing the full system diagnostic, make sure everything's working. Interesting. Oh, there it goes. Okay. I was going to say, it's stuck at 20 volts, 5 milliamps, but then it started up. Okay. So now we're waiting for Apple logo. Apple logo, Apple logo. And it's charging the battery, so the battery's good. We're pulling over an amp, but that doesn't tell me like the boot currents. I got caps lock light, so that tells me that it's on. Okay. Caps lock light you can see is on. I got no image. Let me make sure my screen is fully seated properly. Maybe they've got a bad screen. The screen is seated. It's fully plugged in. So we fixed the computer to the point it's turning on. Now we just have no image. That might be a bad display cable. It could be a display. We're going to find out here. Let's see. I'm tapping the caps lock light to see when it comes on to know that I'm fully booted. I'm even looking for an Apple logo that's like barely lit to see if I have no backlight, but no, there's my caps lock light again, and I've got no image, not no backlight, but no image. We're just gonna clean the screen a little bit, make sure I don't have image versus no backlight. Okay. Alright, and so we're gonna just go ahead and unplug the computer. We're going to do, the first thing I'm going to check even before the screen is I'm going to check this ribbon right here, okay, that actually goes from the board to the screen. I see that fail very often. And it's really only the screen, that's the most expensive piece. So we're going to hope it's just this display ribbon here and that we get Apple logo. So if we don't get Apple logo here, we're going to hope the board is still bad in some way, because I don't want to have to tell the client, like, hey, your screen is also bad. But it's booted up again. There's still no image. Okay, let me go find a known good screen. And I'm not going to put too much time into looking for a screen that I can't find. I don't know. I mean, whenever you can't find a piece, you're like, I don't know, did I sell it, or I don't remember. So right now we got the unit turning on. We're going to put all the screws and everything together, and we're going to put it to the side. Just let the client know, like, hey, we think we fixed it, but it's got a bad screen, we're pretty sure. So we got to order a new one and make sure that that's what it is. I hate when this happens, but it does happen sometimes. So really not much we can do about that, but I think I fixed it, and that'll be good. So we are going to move on to the, I think this is the M1 no power. So we're going to do the same thing. I'm going to switch it overview. We're going to plug it in, and see what we get. Okay, so this one's a little different. We got 5 volts. We're actually getting 20 volts. It looks like it's booting up for me. Oh, was this no image actually? Yeah, no image, not no power. What am I thinking? Okay, so what we're doing now is instead of, we're gonna face it this way just to see if we have no image or no power or no backlight, because sometimes it can be hard to tell the difference. So we're gonna make sure we got it turned off. We're gonna restart it because it's easier to see the Apple logo versus like the login screen. Because the Apple logo is white on a black background, so it's very easily identifiable. And no, we have no image, so they were correct in their diagnostic. So we'll go ahead and pull the back cover off now. All right, this one doesn't look worked on at all. Wow, fantastic. Gotta love that. That will be a time saver. So we are disconnecting the battery. And since on the M1 Pro, the image circuit, or some of it anyway, is right here, right on the top. So what we're gonna do is open up the MacBook so it stays awake and it doesn't go to sleep or anything. And we are gonna test some voltages, okay? So let's pull you over to the screen to see what we're gonna test. What is this, a 2020? Right here, okay. Okay, all right. So up here's what I'm talking about. We have 5 volt for the LCD, and I think over on the other side we're gonna have 3 volts. Yes, okay, perfect. And then we're also gonna test right here. So that's like the final stage. So all right, we're gonna do that first. And I'm not even gonna use the scope for this. We don't need to. Gonna test there. We get no voltage. None. Nada. Hola. Nothing. Nothing. Okay. We have already found our issue. Alright, batteries disconnected. We're going to just check, see if that line shorts. No, it's not short. No, not short at all. Okay, let's go. I'm happy. This looks like it may be an easy one. So we're going to go ahead and take the board out of the housing. Let go. There we go. All right. There's something weird. Something weird. I see liquid damage. One looks like Sharpie. Let's see. Okay. Okay. So we definitely have some liquid damage along with several components knocked off the board. Look at that. Even the ribbon itself has been hit. So let's see. It's hard to tell at this point. This has really been worked on, or I think that's no stuff. I don't remember off the top of my head. We'll have to look here and see. I'm just taking this ribbon off here so I can get a better view of the connector, make sure that's not damaged at all. No, that looks good. And on the other side, yeah, that looks good. It looks like the metal was just hit there, so that should be fine. So you can see that we have, maybe you can see if you weren't out of focus at all, we have what looks to be like a missing component here. This may be no stuff. If it isn't no stuff, we're going to have to relay some of these traces. It looks like this may be missing. This has definitely been scratched away for some reason. Maybe this has been, no, I don't think it's been replaced because you can kind of see some of the liquid down in there. That's definitely needed for image to work, or backlight, I think maybe. This resistor looks like it's barely hanging on maybe. That one's definitely barely, ooh, yeah, see that one was barely hanging on, just knocked that one right off the board. That one maybe needed to be replaced. So I don't even think this is all for image. It may be, but we're gonna go ahead and get to work. So first what we're gonna do is we're actually going to look at a donor board. So I find it's easier, I mean, because you can look at the schematics in the board view and tell, hey, this is no stuff or this is missing. And a lot of times you can even identify it by eye. Like you can just kind of look at it and say, hey, look, that's obviously no stuff. But the easiest thing to do and the quickest thing to do is to simply get a donor board if you have one and look at exactly what's missing versus what's no stuff. And Sorry, it took me forever to find the donor board here. So what we're going to do is kind of just put these on top of each other and do the scope, zoom out as much as we can. All right, and kind of see. So, all right, so I was right. This here, where it's been gouged away, is no stuff. This component here is nothing there. And hold on. What am I working with here? 2020. Yeah. Why? That's weird. I might have pulled this off with my donor. Oh yeah, I did. You can tell I pulled off mine. All right, I was like, what the heck? I'm missing a piece on my donor. But no, I pulled this off before. Okay. I was like, what in the world? I was thinking I was dealing with the M2 MacBook Pro for a second. But no, we're in a good spot here. All right, so looks like nothing is really missing over here. If we move up a little bit, we're missing this resistor. I believe that was the one I just knocked off. So we seem to be, we don't have too much damage here. I think we're going to be able to make this a pretty quick and efficient repair. A lot of these test points are damaged, so I don't like that. Let's see, I'm kind of looking like, so you see this one here, how you have, it's actually easier to see on this board. So on this trace, you see this test point here, you see how you have a trace point ahead of it and then a trace point underneath it. A lot of times you need that test point to make that connection, so it's nothing is breaking inside. So we're probably gonna have to lay a jumper from here to here to get that to work. We're probably gonna have to replace this chip because you can see here our test point is just completely gone. So I'm gonna lay a jumper from there to there. I'm gonna replace this chip. I'm gonna replace that resistor that I pulled off. Then we're gonna start messing up around here and seeing if we can clean this up a little bit. And hopefully, I don't know if this test point is just a test point or that's a broken trace. We'll have to find out in a second. So let's go ahead and get started. We're going to get started with this chip here. We'll pull that off and see what kind of damage we're looking at underneath. So really we haven't even started diagnosing the lack of the 5-volt line being there. We're going to address just the obvious damage that we see here. Okay, see why we do address the obvious damage? You see that we have a missing pad or a damaged pad right here. That clearly wasn't making connection. If we actually look what that chip is for, I already know it's something due to image. I don't remember if it's backlight or image, but if you know that one can affect the other, definitely on this. So we're going to search, see what it actually does. And you can see it's for backlight and for image. So you can see it's LCD power enable is going into the chip, and EDP panel, like the LCD panel enable, is all on the right side of the chip. So this is, and then if you look here, boop, and follow the line, it leads to the chip that turns on 5 volts. So we're in the right area, definitely, of why this MacBook isn't working. We're going to go ahead and grab another donor because you can see mine has that piece that's missing. Hopefully it doesn't take me as long to find another donor. Alright, there's one with the piece we need. And hopefully the piece isn't damaged. Alright, so that's the piece. Oh, might help if you guys were on the scope. Oh, hold on, what am I doing? What am I doing? I'm going out of order. We need to fix this first. Boom. I'm getting ahead of myself here. Dun 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 dun. Yeah, some Lux. So that pad may be just dead. Alright, we're gonna try to revive it, but I don't even know if there's a pad there left to revive. Alright, let's see what we're working with. Now we can clean this flux away and kind of see what we're working with here. Okay, do we have pad? it's still hard to tell if we have pad or no pad. Try to make it as clear for you guys as possible. So what we're going to do is we're going to take our little X-Acto blade. We're going to scrape a little bit. And we have pad. We have pad. Alright. Yay. Now we're going to put our multimeter in diode mode and make sure that the trace isn't damaged. It's not. You can see that those 2 points are connected together still. Perfect. We're going to add more flux. Just like that. And we're going to apply some solder here to it. Just like that. Right? Now we can install our new chip onto the board without a problem. So we're going to leave that flux on there. We're going to pop our donor on our desk. Pull this chip off. Wow, I don't know why I can't keep us both in focus at the same time. Bam, just like that. Alright, cool. That chip is going to be good to go. I'm going to clean up our fluxes. I don't think I'm going to have to ultrasonic this board. I think if we just kind of take care of it and keep it clean throughout the process, we should be good to go. So we are on this one. We're going to clean just as I normally would. Perfect. Alright, so now what we want to address is this resistor here that's missing. Or it's not really missing. I threw it away. I totally wrecked it. Alright, let's see. We're just scraping the pads to bring them back to life. Just like that. Okay. Now we're going to pull up board view here so we can see what they lead to, because one of them, it looks like maybe have a damaged test point next to it, and that could throw us off. So where is that resistor? It's this one here. So that goes to NAND. Oh, fantastic. That's what it fucking wanted. Ah, okay. Oh man, let's see if we have a diode reading there. I hope we do. Oh my goodness. Come on. Yes, okay, thank God. Alright, I thought I was about to have to dig under the NAND for a second to grab that test point. That would have really stunk. Wow, that would have stunk a lot. Alright. Oh, you guys are still on board view here. Let me swap you over to scope. So, we did test this point here, the one that went underneath the NAND, and that did give us a good reading. So we're going to go ahead and replace that resistor here. Put some solder on those pads. Stick, son, stick. There we go. There we go. Yeah, that's good. That's good. Now, I'm not really being very easy with my Q-tip, and I'll tell you why. Because you saw how that capacitor to the right just flew off. That's what I want. I want to know if something that I need to be there is going to fly off. That's important for me to know. Alright, so let's just go to our donor now. We're going to find that same resistor. And honestly, so if this is to the NANDs, this unit, you heard it, it did power on. So it means that resistor was working, but you saw how easy it was for me just to pick it off with my tweezers. So it really, it would have caused an issue later down the road if I didn't mess with it. So I'm glad I did, and I think that's exactly how you're supposed to do it. If something doesn't look right to you, or it looks like it's barely hanging on, then the best thing is to replace it, because you don't want the board coming back to you in a month or two, because it makes you look bad also. Ah, you're kidding. I just let go of that dang resistor. Oh my goodness, what a new mistake. Wow. I lost it. That resistor is gone. Now we're going to have to pull this one. Wow, what a new mistake. Alright, let's hope I can take better care of this resistor. Alright, so now we got the resistor stuck on there a little bit. We can give it just a drop of flux. Whoop. Perfect. That resistor's on there. We are got a couple more steps before we test it again. Alright. Now we're going to deal with this mess in here. Okay, so here's what we're going to do. So this test point and this test point are eaten out, right? But here's the thing. You have a trace right here and a trace right here, and they need to be connected. Same with this one. You have a trace right here, and they need to be connected. That was the job of the test point before they got rotted away. So now it's our job is to scrape it away and rebuild it. So we're going to start with this one on the tippy top. Just slightly scraping. Trying to expose the copper underneath. The pad underneath, the trace. There we go. That should be good. And we're going to do the same on the bottom. Just like that. Oh, my camera went away. I don't know how long. Alright, so my scope camera is actually working again. Perfect. This is very annoying. I would have given up if I didn't tell this client that I would do everything I could to make this video. Alright, so here we are. We're just going to add some solder to these traces there. There we go. Alright. And now we're going to use, I'm going to try to use this thicker wire. I like to use the thicker wire on MacBooks. More solid connection here. So let's see if we can get away with it. Sometimes the trace is just too... where'd that wire just fling off away to? Oh, there it is. Across the board. Sometimes the traces are just too thin to use this wire though, so let's see. We're going to do just a tad more flux. Spin this wire around. I guess I can get a better grip on it here. There we go. Come on, keep coming. That's perfect. Right about there. Alright, that should be stuck on there pretty good. We're going to attach the same thing down here. Come on. Perfect. Alright, so that's a good installed wire. We're going to cut the access off. We're going to try to use that wire again on that next piece. So we're going to put that off to the side up. You can see I just kind of put it above where we're working. Now we're going to clean up the flux to make sure everything is solid and to scrape up the next trace. Alright, so yeah, that wire looks like it's on there pretty good. It's not going anywhere. We're going to do the same thing over here. should be good on that one. And we're going to just try to scrape a little bit right here. Alright, just like that. And so I also see like a little via in the middle there. So I'm going to try to attach that too. That could say that, hey, like I'm going somewhere else, so all three need to be connected together. And I'm just checking to make sure none of these are ground. Alright, not ground. OL and OL. Yeah, so you can see that those are all going to need to be connected together here. So we're going to add our flux. And I'm just thinking of memory. I think these all control something with camera. It may be with image, but I'm actually thinking this for camera. Maybe there wasn't a via in the center. It's gone. I'll dig there a little bit to see, but I don't see even a trace of a via anymore. I think I might have just had something sitting there that I didn't clean up very well. Let's see. No, there's not even a trace of a via. Okay, that was just some of that test point that was still hanging on. Alright, cool. We're going to do what we were initially planning anyway, which is to run the jumper from top to bottom with no center point. Alright, and man, that's perfect. Come on, attach. Awesome. And again, we will cut off the access wire. That should be good. Alright. Alright. This is going to be a working MacBook, hopefully. We got to keep our hopes up that this is all this MacBook needed. Alright. Okay. So, now the last step before we test is some UV mask to cover up our work. We don't want those wires exposed. It's not like it would hurt anything if they were exposed, but you just want to keep them covered up. Maybe if somebody sees a little sparkly thing in the future, they knock it off. So we just cover it up, make it look like nothing ever happened. I'm using black just because that is the color of the board. I try to match it as close as possible. All right, and a little bit over here as well. That should be more than enough, actually. Alright, so we're going to go ahead and cure that. Where am I working? Right there. Alright, we're going to cure that. We're going to clean up the excess UV mask on my desk because that can become a mess if you don't clean that up right away. Oh. Don't. Alright, that should be good. Alright, we're going to put the same display cable on there. We might be able to get away with it. Like we said, we looked at it before, and it looked like they weren't damaged at all. Or the ribbon wasn't damaged at all. Now, that doesn't mean it's not damaged, but we're hoping. We're hoping. And we're hoping that the display works as well. That's not on there right, but it's okay. All I need is the display and the USB port plugged in so I can see if I get image, and then I'll put the board properly in there, and we'll call this MacBook fixed. Hey, Apple logo. Beautiful. It restarted. That's kind of to be expected with the M1 Pros. But that's exactly what we needed. Image to work. Perfect. Alright, so this one MacBook is fixed. Now we're going to go ahead and just put it back in the housing. Wait. Look, it's still turning on. Make sure it boots up actual to the lock screen here. A lot of people don't like to give out the password, so we will see if it's password lock. Like sometimes it's just 1, 2, 3, 4. It looks like they're selling this computer, maybe, I don't know. All right, so it's booted up into recovery. So we're just gonna restart into the OS. Alright, so doing disk utility, see if we see the drives or anything like that. Yes! Alright, so we see... Okay, so it does see the NANDs. It's showing it weird. It's not showing it normal. So likely it just needs an OS install. So we're gonna put this aside for right now and ask the client if they care about data. Otherwise, we're just gonna reinstall the OS. All right. So this last one here was, from my understanding, high fan. This is the client reached out about this MacBook. He said it has high fan spin. It had already replaced the battery. And it still just has high fan spin. From my memory, it does not run off the battery. So with this particular model, really with any MacBook from M1 or from, I'm sorry, T2 and newer, any MacBook Air will have run like crap if the battery's not plugged in. The fan will spin real high, and it won't run off the battery. And that's because it has a thermal sensor inside the battery to tell it that the computer's not on fire, right? So whenever the battery's not plugged in or the battery is bad, it thinks that, hey, the computer's on fire, slow everything down, turn the fan all the way up, and that's what you get. So you can see, maybe you can, charging at 20 volts, 500 milliamps, which is just enough for the board. If I unplug it, you see it dies right away. I am almost positive this is the battery. I think I've only seen it once out of all the times I've seen this issue, it be something to do with the board that was causing it. And I believe that was tech damage. I don't quite remember now that I'm thinking about it, but it's very rare for you have this issue and it not be the battery. I did tell the client this, but he said he tried, I think, multiple batteries and it was the same problem. So this will either be number 2 that I'm fixing this and it be the actual logic board, or it's a bad battery. And it will be very easy to tell because I got a battery ready for testing. And you can already see it does have the new battery in it from Mobile Centrics, it looks like, but it's not plugged in all the way. It looks like it's plugged in all the way, but these batteries can be tricky and you gotta push it down and then jam it in. So how much do you want to bet that is gonna fix this MacBook? Let's see. I bet the client will not be happy if his battery was good but just not plugged in. I would laugh. I think that's funny. It's already starting to charge. That's all that's wrong with this MacBook. Yeah, it's charging. It's charging fine. And it's not on yet. Let me switch you back over to overview. Oh, there, it just turned on. Now if we unplug it, it stays on. And I don't hear no fan. I don't hear no fan. No fan. So, bam. This is a working MacBook. This is fixed. Yes, we are good to go. All right, so let's overview. It shows 62%. It booted right up. It's not running slow. It's running perfectly fine. Okay, so that's fixed MacBook. So let's review. What did we do today? So first we had the MacBook Air M1 no power, and that one had a little bit of work to it, so that one was kind of a pain. So first it came in with a PP bus not being generated, and that was due to the ISL having the not having the crack in it. We replaced that. PP bus was being generated. Then we realized that 3V8A on was not turning on. We investigated that, and we realized it was not even being told to turn on. So we went further down the power structure and figure out why it wasn't being told to turn on, and we found a little chip that had a hole in it. Visual inspection should have caught that right away, but we missed it. But that one is working other than it has no image. And again, we just have to wait for a screen to see if it's just a bad display. I think it is, because when probing around, I found the 5 volt and the 3 volt line were there. So it could still be a board issue, but it's likely just a bad screen. So we'll investigate that later. Likely won't be in this video. You'll just have to trust me that the board is fixed. On the MacBook Pro that came in with no image, we saw liquid damage. That one hadn't been worked on before really extensively anyway, so that was pretty good. We had to replace one of the display drivers and then run some jumpers for the front camera, so we were able to get that one fixed, and that one's up and running. That one does need an OS reinstall though, so we'll get with the client, see if he wants us to install the OS. And then we had this MacBook Air that had high fan spin and wouldn't run off the battery. Told the client to go ahead and change the battery. He did that, but he didn't plug it in all the way, so that was the cause of that. So we had those 3 MacBooks. We also have an iPhone of his to look at. Again, that's not going to be in this video. I think this video is already too long. So I'm going to go enjoy the rest of my Sunday, and I hope you guys enjoy the rest of yours.